In residential neighborhood, traffic engineers are studying the flow of cars entering through three main routes: Rose Road, Orchid Road and Kenanga Road. Cars from this road merge and pass through three internal junctions: Junction A, Junction B and Junction C. A traffic survey recorded the total number of cars arriving at each junction as follows. Using Gaussian elimination method, determine the number of cars entering each road.
Purpose of study. The primary purpose of this study is to apply linear algebra concept to solve real-world traffic engineering problem. Especially, the goals are: firstly, to determine the unknown number of cars represented by variable P, Q, and R entering from Rose Road, Orchid Road, and Kenanga Road. Secondly, to demonstrate the step-by-step application of the Gaussian elimination method in transforming a system of linear equations into raw echelon form. And lastly, to analyze the resulting traffic flow values and discuss their implication for the residential area's traffic management.
Now, we will get into the methodology, steps on how to solve the questions. Since the question asks us to solve the question using Gaussian method, we need to form the augmented matrix for the first step. Write the system of equation in the form. Step 2. Make all entry below the leading one on the first row into 0. As we could see, there's number 2 and 1 below the leading one of the first row. We need to turn all the entry below leading one into 0 by using elementary row operations. We need to multiply first row with a non-zero constant, which is -2, and add it to the second row. This will change the second row number, and we also need to do the same thing for the third row. Multiply the first row with -3 and add it to the third row. Step 2.
Next, we will proceed to the second row. As we could see, the second row doesn't have a leading one, so we need to find the leading one. By using the elementary row operations, we multiply the second row with a non-zero constant, which is -1/3. Now that we have the leading one for the second row, we need to make the entry below leading one of second row into 0. Like the second step, we multiply the second row with 5 and add it into the third row. For the fifth step, we proceed with finding the leading one for the third row, as we could see that there is no leading one yet. Multiply the third row with -3/8, thus we get the new third row. After that, we need to convert the value from the augmented matrix into the system of linear equation. We will read the matrix from below to top. R is equal to 115/2, Q minus 1/3R equal to 130/3, P plus 2Q plus R equal to 220. Lastly, we solve the system of equation. We already have the value of R, which is 115/2. Now we only need to search for the value of P and Q. For Q, we will use the equation Q minus 1/3R equal to 130/3. Substitute the value of R into the equation, and then we can calculate the value of Q. The value of Q is 125/2. To find the value of P, we use the equation P plus 2Q plus R equal to 220. Substitute the value of P and R and calculate the value of P. P equal to 75/2.
As for the discussion, the result shows that the Orchid Road Q has the highest volume of traffic near entering the neighborhood, which is 62.5 cars per hour, suggesting it is the primary access route. As for the Rose Road traffic, it contributes the least amount of traffic, which is 37.5 cars per hour. As for the result, by employing the Gaussian elimination method, we have successfully solved the system of linear equations. These calculated traffic flow rates are Rose Road P 37.5 cars per hour, Bukit Road Q 62.5 cars per hour, and Kenanga Road R 57.5 cars per hour. These specific values represent an average rate of flow per hour. This is common in statistical traffic surveys where averages are used for planning.
So, from this study, what is the conclusion that we can achieve? This study shows how linear algebra can be used to understand and solve real traffic problems. By using Gaussian elimination method, we were able to find the number of cars entering each road and analyze the traffic flow. The methods help us organize the information clearly and get accurate results. Overall, math help us understand the traffic flow and how it affects the neighborhood.